Okay, so good evening. I am Somapna, research scholar at the School of Mathematics and Statistics, University of Hyderabad. So today I will solve a problem from assignment 9 of previous years. So let me show you the questions first. Question is, I will start with question number 2. So the question is, let D be a dx in R2 and U is a twice continuously differentiable. U is the minimizer of this functional J, where J defines from S to R. S is a set, those V such that V is 0 on the boundary. So you have to find which one of the following partial differential equation satisfied by U is in D. Uh, satisfies by U only. Which of the following partial differential equation satisfies by U in this domain D? So U is the what? U is the minimizer of this functional J. So first you have to find, that means you have to find the PD which satisfies by this minimizer of the functional. So let me do this. So let me write the problem here first. So the problem is that to deviate dx in R2, and let U be the minimizer. U is a C2 function, twice continuously differentiable over D and its boundary. Be the minimizer. Minimizer of this J is S to R, where S is given by S goes V such that V is 0 on the boundary. Now, what is the minimum functional is given as J of V is integral So now I will find the PD. So let me first, I think you know the procedure. First we have to define one function h, which is we define h of t is the functional at u plus t of v. Now since u is the minimizer, that means derivative of this j is 0 at t equal to 0. That means, okay, since u is the minimizer, so let me write what is j u plus tv. That is u plus tv is this. Just I replace v by u plus tv, okay, in j of v. Okay, so now at t equal to 0, it is 0. So what is the derivative? That means you have to find the derivative of h. That is h dash t we have to find. What is h dash t? He showed that you have to use the Newton in this formula here because you have to differentiate under the integral sign, right? So h of t is d dt of integral of this. First I will find the derivative, then I will put t equal to 0. So, so can you tell what should be the derivative of this gradient? Gradient square? No. Anyone? Kishore? Otherwise I will tell.
Kishore has left, so you just continue.
Okay, I think he left. Okay. Okay, I will continue.
Huh?
Yes, I will continue. I will continue. No problem. So, the derivative is just this is 2 into minus. Grad means square root of. Grad square means you that partial derivative with respect to x of this function u plus tv square plus u plus tv partial derivative with respect to y square. This is grad square. Okay. Now I will differentiate this grad now. So this is, since it is, I'll differentiate this grad. So since it is a square root function, so square root means 1 by 2 root partial derivative. So, and into the derivative of this term inside this square. This is just chain rule. Since I am differentiating, now this is the first term. So what will be the second term? Right? Derivative of the first term. The second term is 2 v dx dy. Okay. So now I will simplify this thing. Simplify means I have to find the derivative at t equal to 0. So I will put t equal to 0. So h dash is 0. Let me write for minimizer of u. I have h dash 0 is just I will put t equal to 0. That is integral over t 2 grad u into the term in the, this is also grad u at t equal to 0. Since I am putting t equal to 0 into 2 into, I am putting t equal to 0, so that is ux plus vx. Ux into vx plus uy into vy. 2 I take common, so that means grad u dot grad v, right? Because grad u means derivative, grad u means ux and uy, and grad v means vx here. If you can check it in terms of vector, then dot product is ux vx plus uy vy at t equal to 0. I am taking here. So this is this minus 4 uv into 1 plus 4 uv into 1 plus u square into dx dy. Okay. So this here you can check that this cancel out. Only thing these two also cancel out. So I got h dash n0 as h dash 0 as 2 into grad u into grad phi minus 4 uv into 1 plus u square. This integral. So let me write it in the next page. So h dash 0 I got as integral over t 2 into grad u dot to grad phi minus 4 uv into 1 plus u square. The total integral over the region D. Now for the minimizer, this is test 0 is 0. So I will calculate for which u this satisfies. So now h dash 0 is equal to 0. So this integral equal to 0. Now I will integrate by parts to get the PD, the required PD. This is true for all v. So this is true for all v. So now integrate it by parts. Integrating by parts. I will write the formula. Okay, let me write the two. Let me take 2 common from here, and then I will write directly. So it is minus. I will write the formula. Let me first write the formula, then for integration by parts. Here in bracket. So integration by parts means suppose u and v are two continuously differentiable function. Say first order derivative is exist and it is continuous, then integral over any omega u dash into v dx. I am taking first single variable, so this is equal to minus integral over omega u v dash dx plus integral over the boundary u v into the outer term normal vector, so mu I into d of s. S is the surface on the boundary. So this is the integration by parts formula. Now I will same thing I will do here. So here what happened? Here I am taking this u as I am taking this u as grad u as I am taking u as grad u and v as grad of v. Just so it becomes. Let me write it here. So this becomes integral over t minus, here derivative means grad. Here I am taking here I am in my formula I am giving for single variable and a single independent variable. Now here it is grad because here the dx dy integral double here. So grad u into v dx dy plus integral over this boundary v into grad u into mu y d of s minus again this part I will remain same because I will not changing this part 4 into let's I think I did something here is a by 2 is there total thing by 2 is there here by 2 so this is a bracket so here also by 2 is there so that means this 2 is cancelled out this 2 and this 2 okay so I will get only grad u dot grad v not 2 into so here it equal to minus 4 into 1 plus u square into u v dx dy that is equal to 0 now on the boundary I know that v is 0 because my S set is given as the set S is given as those v has that v is 0 on the boundary so v I take 0 so integral over del of d this v integral becomes 0 this integration equal to 0 because as v equal to 0 on boundary okay so I got this equation as minus grad of grad means Laplacian right Laplacian u into v dx dy minus 4 into integral over d 1 plus u square into u v dx dy equal to 0 now I am taking common I am writing like this minus so minus I am taking common so I need to write minus integral over d grad u plus 4 into 1 plus u square into u of v dx dy equal to 0 for all v this is true for all v right say I am taking arbitrary v at first j of u plus tv and v is anything now this is true for all v's so this is true for all v means this part grad u plus 4 into 1 plus u square into u this is equal to 0 because you know that from one result of real analysis is that integral of some f into phi dx equal to 0 for all phi then my clear answer is f is identical equal to 0 okay this is standard result for all phi is a c infinity function means here it is suppose say c infinity function okay then f is my this is a result from real analysis so here my the pd the here the pd that satisfies by u is given by this grad u this the Laplacian u plus 4 into 1 plus u square into u equal to 0 okay so this is the answer so answer is this so let me check what is the what are the possible options the possible option is grad u plus 4 into option is f I got grad u plus 4u into 1 plus u square equal to 0 so my option is f so now so answer is f. Now I will move to the next question. Next question is question number 4. Question number 4 is that let me show you the question. Question number 4 is for a differentiable function f let u be the solution of the initial boundary problem ut2 minus uxx plus fu equal to 0. Ux comma 0 is 0 and utx comma 0 is 0. And on the boundary u is 0. u0t is 0, u1t is 0. Now the function is given by one another function e. E of t equal to integral 0 to 1 ut square plus ux square by 2 plus g of u. And which of the following choices of the function of g, the function t is a constant, t goes to et is a constant function. So let me write the, I think you saw the question clearly. So let me, this is the question. So let me write the question in this. So differentiable function u is the solution of the series of our problem that u50 minus uxx. So y equation plus a field, that is a reaction term is there. The problem is 0. T is positive. Ux comma 0 is 0 and ut at x comma 0 is 0 for 0 less than or equal to x less than or equal to 1 and u0 t on the boundary u is 0 and on initially also u is 0 around the both boundary for every t positive. Now I have to find another function e is given, so I have to show that which of the following choice of g is constant. Define that is given in the question. E of t equal to integral from 0 to 1 ut square plus ux square by 2 plus g of u t of x. Okay. Now we have to choose g such that t equals to e of t is a constant function. So what is our aim? Our aim is to find the g. So what I will do is that I found that let me do it. I write the equation first. Utt minus uxx equal to 0. And I will multiply this by ut and integrating in space over 0 to 1. So let me write. Integrating space. I just multiply by ut and integrating by parts. Integrating, I will use by parts method. Okay, there is some few terms there, sorry. So utt minus uxx plus f of u equal to 0. So now I will use the integration by parts in the second term. So let me do one thing. Let me write the first term as half of ddt of ut square, right? Because derivative of ut square is 2ut into derivative of ut is utt. So 2 to cancel out, that's why I put half. Now let me write the second term as it is, and third term also as it is. And now I will use this formula that ut into ux, this derivative with respect to x is ut into uxx plus utx into ux, right? So I will replace this ut into ux's here by this formula. Okay, so I will get integral 0 to 1. This first term remains same. Minus. I just replace the second term. So I am getting, now I will use what I am getting, I will tell you. I will not use bypass here. I will directly calculate. I will directly integrate because here it is my derivative of with respect to. It is here derivative with respect to x, and I am getting integration also with respect to x. So the derivative of a function again I am integrating this. So it remains that the function only. So I am just putting a function that is ut ux at 0 and 1. We don't want the values of x. Okay. So this is the integration, and this part is, this can be written as again half ddt of ux square, right? Because ux square is ddt of ux square is 2ux into uxt or utx. They are same. So 2ux into uxt or utx. So 2 will cancel out with half. So I will get utx into ux dx, and this part is same. Somebody wants to join or something. Okay. If of t dx equal to 0. Okay, so I will write. I will merge this first and third term. Okay, so this is integral of ddt of ut square plus ux square dx minus ut at 1t into ux. I am putting just a value minus ut at 0t into ux at 0t, right? So all these are 0 because it is giving that. Let me show you this. U 0t is 0, that means ut at 0t is 0, u 1t is 0, so that means your derivative is 0. So all these things are 0. So and the last term is integral 0 to 1 f of u ut d of x. So here the term in the square bracket is 0. So I write again integral 0 to 1 half of ddt of ut square plus ux square dx plus integral 0 to 1 fu into ut dx equal to 0. That I got finally. Now now what I will do, I want to compare this with my e, capital E, and e is giving us this half of ut square plus ux square plus g of u. So what is my e dash? E is given as e of t is half of integral 0 to 1 ut square plus ux square dx plus something plus g of u. Okay, since I take half here, so I will write integral g. Now what is e dash t? E dash t is e dash, the first part of e dash t is same as this first half of this integral. So let me write what is e dash t. Derivative by using differentiation under integral sign is to it is d dt of ut square plus ux square dx plus d dt of integral 0 to 1 gu d of x, right? Or you can write the integral inside. So what I will get if I compare this with these two, I will write in the next step. I will get half of e dash t plus integral 0 to 1 ddt of g of u into d of x equal to 0. So if I compare these two, I will get I will get integral 0 to 1 c dash u into ut d of x equal to integral 0 to 1 fu into ut dx, because I am taking those g such that t goes to e of t is a constant function. That means e dash t is constant function. That means e dash sorry constant function. That means my e dash of t equal to 0. So if I compare this, I will get this thing. So what is g from this? If you compare this, that means g dash u equal to fu, right? Because as I told you that integral over f into phi dx equal to 0 implies f equal to 0 for all phi in situ. Here my phi is here. This my phi is u of t, nothing. So if g dash u minus fu equal to 0, so that means g dash u is identical equal to fu. So that means gu equal to integral of 0 to u fs ds. This is my g. This is the answer. So let me show you first. This is my answer. This is a formula that I used. Hence, this is my answer. Okay, so my answer is. So let me check which options are correct. Correct option is I am getting g equal to integral 0 to fs ds. That is option E. So option E is the correct option. Option E. Option E. So now I will move to the next question. Question number 6. Question number 6 is it will be the generalized solution of this Cauchy problem. The function Cauchy problem is given as utt minus 4ux is 0, and initially ux comma 0 is x into x minus 1 and x belongs to 0 to 1, 0 otherwise. And utx0 is 0, that means the velocity is 0. The function u is not a classical solution in the neighborhood of which of the following points? Is not a classical solution. That means they have some singularity. Classical solution does not have some classical solution, means it has some singularity. So let me just write the equation, then I will tell. So the Cauchy problem utt minus 4 ux is 0. X comma 0 is x into x minus 1 if x lies between close interval 0 1. 0 and 1 and 0 otherwise, and ut x comma 0 is 0, x is in R. So see, you have to find for which of the following points. Let me show you the question. Which one of the function is not a classical solution in the neighborhood of which of the following points? Not a classical solution means it has some singularity. So you have to find in which points these have some singularities. So you know that singularities travels, singularities of U solution travel along the characteristic line. Okay, so so let me write this line that singularities travel along the characteristic line. Singularities travel along the characteristic lines. So what are the characteristics? Here what is the speed? C is 2. Right? The C squared is 4, so C is 2. Here if you compare with the general wave equation, C squared is 4. That means C is equal to 2. So what will happen is that the characteristic are given by x plus ct equal to 0 and x plus ct equal to constant and x minus ct equal to constant. So the characteristic are given by x plus 2t equal to x minus 2t and x plus 2t. Let me write x minus 2t equal to some c1 constant and x plus 2t equal to some another constant c2. Now let me show you the question again, that u is given at initially given at 0 and 1. If x lies equals to 0 and 1, that means u passes through x equal to 0 and x equal to 1, these 2 points also. So let me find the characteristic are passing through x equal to 0 and x equal to 1 also. So let me find the value of c1 and c2. So now characteristic are passing through x equal to 0 and x equal to 1 line. So what are the lines then? X equal to 0 means x equal to t is always 0, x equal to 0, t 0, because I am initially taking t is 0, u x comma 0, that is u x equals to 0 to 1, so x 0 t 0, that means c1 is 0, so the lines are characteristic passing through this line. So let me write in the next page that so the characteristic are given by L1. First line is L1. Let's say the x minus 2t equal to 0 because passes to 0 0. L2 is x minus x plus 2t again 0 because it passes to 0 0. L3 is passes through 1 0. So x minus 2t is 1 and again L4 is x 1 comma 0 passes through. So x plus 1. So if you know the singularity lies on these lines, so if the points lies on any one of these lines, then the solution is not a classical solution. That means the solution have some singularities. So if the points lying on these lines, then there are singularities, that is u is not a classical solution in the neighborhood of these points. So now let me write, if the points are given in these answers, you have to check the answer. the points lying on these lines, then these are singularities. The, these are singularities, right? So that means U is not a classical solution in a neighborhood of these points. So let me show you which one of the following points lies on any one of these lines. Then U is not a classical solution in this region, in a neighborhood of these points. You have to find the function U which is not a classical solution in the neighborhood of these points. So first is option A is minus 2 comma 1. So let me write minus 2 comma 1. Option A minus 2 comma 1. So just clearly check that minus 2 plus I got x plus minus 2t is my characteristic line. So I am putting x equal to minus 2 and t equal to 1. So x plus 2 into 1 is equal to 0 volts. So that means it lies on L2. Lies on my L2. My L2 is what? L2 is x plus 2t equal to 0. That is lies. Option B check. Option B point is option B is minus 5 comma 3. So that means minus 5 plus 2 into 3 equal to 1 volt. So that means it lies on L4, right? So now similarly option C is given as 1 comma 2, but it does not lies anywhere. L1, L2, L3, L4. Next is 3 comma 1. It lies because 3 minus 2 into 1 is 1. So it lies on L3. Option E is Option E is 3 comma 2. It does not lie anywhere because 3 minus 2 into 2 is not equal to 1 or not equal to 0 also anywhere. And option F is 51 comma 100. That is also not possible. X plus minus 2t is not equal to 0 or 1. Option G is 101 comma 50. This is possible because 101 minus 2 into 50 is 1, right? So that means it lies on any one of the lines. So lies on L, I think x minus 2t, so L3 again. So it lies on L3. So that means in neighborhood of these points A, B, D, and G, U is not a classical solution because because the singularities lies on the characteristic lines. So A, B, D, and D, G are the answers. A, B, D, and G are the options. Are correct option. This is the answer. Let me show you the answer. This A, B, D, G. Okay, fine. You just have to find in where U is not a classical solution. Okay, so let me move to the next problem. That is problem number 7. 7 is that U is a solution of this Cauchy problem wave equation, and initially U is 0 and the velocity is 1 in the neighborhood minus 1 to 1 when x is in minus 1 to 1 and 0 otherwise. Now define a function e of t that is equal to integral u2 square plus ux square dx. You have to find the value of e10. Okay. So the let me write the question in the next page. Question number 7. So now 7 ut2 minus x is 0 when x is in R and t positive. Ux comma 0 is 0 and ut at x comma 0 is given as 1 when x is in minus 1 to 1 this interval and 0 otherwise. Now what is E of t? Define E of t equal to integral r ut square plus ux square into dx. So you have to find what is a question. Question is what is E of 10. That is what that you have to find. So as you know, as I do earlier, what I did in my second problem, I just multiply this equation by u of t and integrating in space. Using the same technique, I will get that I will get that multiply the equation by u of t and integrating by what we get ddt of ut. Here ddt of ut. My here if you compare my question number 4 equation with question number 7, you just saw that there is some f in question number 4. F is there, and question number 7 there is no f. That means f is 0. So if I do the same procedure, multiply by ut and integrate by parts, I will get this like that e dash t plus something, but something is not here. So I will get e dash t equal to 0 because my f is 0 here in question number 7. So let me just not to do the calculation, I just write the from question number 4 that I did earlier. From question number 4, I think question number is 4. Yes, 4. If we multiply from question number 4, if we do the same process, we end up getting, we will get ddt of et is 0 because if you compare with this for question number 4, then you get f equal to 0 by f. So there is no f means f is called reaction term. So there is no reaction term in my this equation. It's question number 7 equation. And question number 4 I got, let me show you again. Question number 4 I got this line. I put right now. Integral 0 to 1 ddt of ut plus integral 0 to 1 fu ut dx equal to 0. But here there is no f here in my question number 7. So I got ddt of ut equal to 0. Right? E is an integral. E is equal to integral over ut square plus ux square. So ddt of ut equal to 0 means ut is constant function. Ut equal to a constant for any t greater than or equal to 0. T equal to constant function. So constant means I can take particularly t value equal to 0 because it is constant for all t. For all t greater than equal to 0, ut equal to constant. So that means for any t it is same value. So I put, for simplicity I put t equal to 0. So what is my e of 0? E of 0 means integral over r ut square plus ux square. So ut square at x comma 0, I am putting t equal to 0, plus ux square at x comma 0, right, equal to into dx. So what is now given? Given is that ux comma 0 is 0. That means ut at x comma 0, sorry, given that ux comma 0 is 0 and ut at x comma 0 is 1 if x lies between -1 to 1 and 0 otherwise. That means ut x comma 0 is only gives from -1 to 1, 1 square, plus this term is 0 because ux comma 0 is 0, so that means ux at x comma 0 is 0, 1 square plus 0 dx. So that means integral -1 to 1, 1 dx. So that means 1 plus 1, 2. So now I got E of t is a constant. E of t is 2 for any t. That means, right? For all t greater than or equal to 0. So I have to find the value of E of 10. So E of 10 is also equal to 2. This is my answer. Because E of t equal to 2 for every t. E of t is a constant function. So this is my answer. So E of 10 equal to 2. Okay, let me do the last problem, question number 8. That shows that u is solution of this Cauchy problem. It's same problem. You have to find u at 0, t. U at 0, t. I will use here do have D'Alembert's formula for simplicity. Just you have to find u 0, t. So let me write the Cauchy problem. This is very easy. I am writing the next page. So write down the equation first. Equation is utt minus uxx equal to 0 for x is in R and t positive, and ux comma 0 is 2 for x is in R, and u t at x comma 0 is sin x cube for x is in R. So sorry, x is in R. So now we have to find u 0 t. What we have to find is limit t tending to infinity. U 0 comma t is what? That is you have to find, right? So that means, let me do the problem here. So you know by D'Alembert's principle. You got u x comma t is what? Half of what is, then my c equal to 1. First write c equal to 1 because utt equal to ux. So uxt equal to half of phi of x plus t plus phi of x minus t plus 1 by 2 into c. C means 1 integral x minus t to x plus t psi s ds. Right? What is phi and psi? Phi is ux comma 0 is a phi of x, and ut x comma 0 is my psi of x. That is my notation. Okay. So I have to find u at 0 t. Then I will take limit as t tends to infinity. So u 0 t is what? Half phi of t plus phi of minus t. I am just putting x equal to 0 plus 1 by 2 integral minus t to plus t psi s ds. Okay, now I will put the value of phi and psi. Ux comma 0 is phi and utx comma 0 is psi. So my phi is 2 and psi is sin x cube. So phi is always 2 for any t. So I will put 2 plus 2. Phi of minus t is also 2. Any t, phi is 2. So 2 plus 2 plus half integral minus t to t sine s cube ds. Now what will be that? Now this integration is equal to 0 because sine s cube is an odd function, and integral minus of a to a an odd function dx equal to always 0. Okay, so equal to 0 because sine s cube is an odd function. Sine s cube is an odd function. So this is equal to half into 4, that is equal to 2. So this is independent of t. U0t is independent of t, I got. So what is my limit? So limit t tending to infinity u0 comma t is equal to 2 volts because this is independent of t. So the limit t tending to infinity u0 comma t is 2 because I have to find u0 comma t at taking limit as t tends to. I got u0 comma t. I got the value of u0 comma t. It is independent of t. So by taking limit nothing will change. So let me just write it quite clearly that the limit t tending to infinity u0 t is 2. So this is my answer. So let me check whether it is yes. So limit t tending to infinity u0 t is 2. The accepted answer is 2 also. So this is my answer. So with this I am ending my lectures today. So this is week 9 we solved. Already Soikat have solved in the previous Friday. Week 9 3 problems, 1, 3 and I think 5. So I solved the rest of the problems. So with this I am ending my lecture. Thank you. Thank you.